Today we discuss what is static allocation and dynamic allocation. Okay. So, Shamla ma'am, what is the syntax for variable declaration?
For variable declaration,
Yeah.
level number,
Yes.
data type name,
Now,
variable name, picture clause, data type, size, value, then assigning value, full stop.
so this is the syntax for the variable declaration. Okay. In level number, we can write 01 and 02 to 49 subgroup variables 66, 77, and 88. Okay. And in variable name, it is a user defined. You can write it by your own. Picture class and data type. What type of data we are storing into the variable. So we are allocating the memory and using value class, we are allocating the value to this COBOL variable. Okay.
Okay, Manish.
So static allocation means within the program allocating allocate the data to COBOL variables. Okay. Within the program itself, we are allocating the value to the COBOL variables. Okay. By using value class, we can allocate the data to COBOL variables at the time of variable declaration only. Okay. By using value class, we are allocating the data to COBOL variables at the time of this variable declaration only. Understand?
Yes, ma'am.
So I am writing one static allocation program. So the program is identification division along with program ID. My program name is sample1. Okay, and environment division, data division, working storage section. So in working storage section, I used to declare the variables. Level number, my variable name is ws num. Okay, I am declaring which variable? Working storage section variable. So that's why I named it as working storage section as a prefix. Okay, and num.
Okay.
So this ws num is my variable name. Okay, so followed by picture class, data type numeric, allocating 4 bytes of memory. Using value class, I am allocating the data. My data is 1959. Okay, and get full stop and procedure division In procedure division, I can write my logic. So I want to display the 1959 value into the school area. So this 1959 value is available in which variable? WS num. We are allocating this data 1959 by using value plus we are allocating to the COBOL variables. Okay. After that, stop run. Okay. This is just a sample program of static allocation. Okay. So one more program for dynamic allocation. There are two ways to allocate the memory to the COBOL variables. One is static allocation and another one is dynamic allocation. Identification division followed by program ID. Program activity. Environment division. Data division. Working storage section. Now I'm allocating my variable 01 WS num and followed by picture plus data type size 5 bytes. Okay, and I'm allocating one more variable 01 WS str string picture class x allocating 5 bytes. Here I'm allocating 5 bytes of memory to variables. Procedure division. In procedure division, I used to accept those variables. Accept WS num accept WS str. Okay. So after accepting, I want to display. So here, can I write this accept two statements as a single statement?
No, Mani.
What?
We should not.
Yes. We can't accept both variable names at a time. We can accept only one variable at a time in the accept statement. Okay. So now I want to display those nums and I want to print one message in between WS num and WSSTR. I want to print at the rate full stop and then stop run. Okay. These two are, this is for static allocation and this is for dynamic allocation example. Okay.
Mani,
But it,
your voice is like not properly. It's not high. Means it's seems like it's from very far away.
means it seems flickering. My voice is flickering for you.
No, not flickering. Means it's looking like you are talking from far away.
Okay. Actually, I forgot it today in my earphones. That's why I'm using earbuds.
Okay, okay, it's okay.
So this example is for static allocation and this example is for dynamic allocation. Okay.
Okay, man.
Yeah. So now we can see the difference between static allocation and dynamic allocation. Okay. So in static allocation, what is the value to receive the value from to COBOL variables? What we are using means we are using value class to receive the data to COBOL variables. We are using value class. Okay. So if you want to within the program allocating allocate the data to the COBOL variables. Okay. In dynamic allocation, we are using accept statement to receive the data to the COBOL variables. Okay. So here we are at the time of execution, we are passing the data to the COBOL variables in dynamic allocation. At execution time, we can pass data to COBOL variable. Okay. So by using value class, allocate the data to COBOL variables during variable declaration only. Okay, by using value class, we are allocating the data to COBOL variables during the variable declaration only. So here, by using in execution process or in execution JCL, we are using instant data concept. Instant data concept, we are passing the data to the COBOL variable. Okay, this instant data concept we can see in our PGM2J XREF. From the bottom you can see sysdd star. Okay, you can see this command in the last line. So we can pass the data. Okay, by using sysdd star we are passing the data to COBOL variables at the time of execution. Okay, that is dynamic allocation. In static allocation, by using value class, we are allocating the data to COBOL variables during the variable declaration only. Okay. If you
Yes,
make
ma'am.
any changes, in the value class data, you must and should do recompilation, then only execute. Compile, then only execute. So if you perform means, so here I am changing my data. Okay. If we change our data means, again we need to recompile and execute. Why? Because means uh, this is a static allocation. That's why we used to do again recompile and execute. Okay. But in COBOL program, in COBOL program using the accept statement, we can receive the data from execution JCL means run JCL. Okay. Here uh, we are passing data from the system registers and we are accepting that variable in the procedure division. So that's a using accept statement we are reaching the data from the execution just here. Okay. So here you can directly change the data in execution just here. So no need to recompilation. Okay. If we change our data means in static allocation, we need to uh, we should do recompile and execution. But in dynamic allocation, directly change the data and execute. You can perform to execution. No need to recompilation. Okay.
Yes, ma'am.
So in this static allocation, um, why? Because means the new data changes. Why? Because means the new data changes will be impact on output. So this is the reason to recompile again in the static allocation. Okay. So the changes in the value class after recompilation, they will update the changes in the load modules. The changes will be impact on the load module and execution changes will be impact on the output. Got it?
Yes,
Hello.
ma'am.
So
Yes, ma'am.
there are so so up to here you clear about the static allocation and dynamic allocation. Any doubt? So here in static allocation, so the value class value class will follow the compatibility rules. Okay, the value class will follow compatibility rules. But in dynamic allocation, they never follow compatibility rules. Okay, static allocation follows compatibility rules and except statement never follows the compatibility rules. Okay, so compatibilities are two rules. Rule number one is so the given data, what is the data you are giving, that is the given data, should be matched with the data type. Okay, what is the data you are giving should be matched with the data type. Okay, rule number two is the picture class length means size is greater than or equal to the number of characters length. Number of characters or digits in the given data. Okay, so rule number one is for the compatibility rules, the given data match with the data type. Here, the given data is numeric match with the data type. Okay, if rule number one pass, the maxi is 0, and the rule number two is the picture class length size greater than or equal to the characters of digits in the given data. Means this data is equal to or greater than to this memory. Okay. Here you can write 5. Okay. You have to give more. Your memory should be greater than or equal to this given data memory. Okay. If rule number 1 fails means we will get maxi 12. So if rule number 2 fails means we will get maxi 8.
8.
Okay. If rule the given data not match with the data type means we are getting the maxi 12. So for the next time the given data match with the data type. But this picture class length is not greater than or equal to the given memory means extra memory is there. This memory is not equal or greater than for the given data. Rule number 2 fails. So that's why we are getting maxi 8. Okay.